Hello everyone, welcome to this video. In this video, we are going to discuss one of the most asked interview questions, singleton. How to create a singleton and how to break the singleton pattern. So first of all, let's understand what is a singleton. Singleton is one of the creational design patterns. It means if you are using singleton, a class can only have one and only one instance on runtime, not more than one. Now, why do we need singleton? Singleton is needed in very specific scenarios when the creation of an object is a costly operation, like when we create a JDBC connection or a socket connection. We want only one object to reside at any given point of time because it takes a lot of time and resources to create that object. So at any given point of time, we want only one object should always be present in the memory, not more than one. Now let's see an example of a basic singleton. So this is pretty straightforward singleton. What we are doing here is we have declared a singleton variable and we have made this private and static with volatile. Static because we want this instance variable to belong to the class and not to an object. Volatile because we want the visibility of this variable across various threads. If there are more number of threads, let's say there are n number of threads, all of them should be able to see the changes happening in this variable, so that we can avoid the race condition between various threads. Constructor we are having as private, obviously because we do not want an external class to create an object of this class. Now this is the crux of the logic here. We have get instance method and it returns singleton object. Inside here we are having a log with the help of synchronized. That means at any given point of time, only one thread will be able to access this block of code. If one thread is inside this block, it will first check whether the instance is null or not. If yes, then it will create a new singleton. Alright, but there is a flaw in this logic. Because the flaw is, if there are 2 threads or 3 threads, n number of threads, every thread will try to get inside this synchronized block, even if it already has this instance variable. So to avoid this behavior, we have a better method which is called as double check locking. Now this is the implementation of double check locking. That means we are locking twice. We are checking twice and locking once. First check is here. If instance is null, then only go inside this block. So if a second thread comes, it is checking if the instance is null. If a thread 1 has already created the object of this class, obviously this check will fail and the second thread will not try to acquire this particular lock. It will straight away come here and return the instance. So we are having first check here and second check here and locking once. So this is the reason that this particular approach is called as double check locking. We check twice and lock once. Now let's try to see if we can break this particular approach. Now in most cases this approach works pretty straightforward. Everything works, and this is the most standard way of implementing singleton. But in your interviews you might be asked how to break this particular pattern with this approach. Now let's see how to break things. Let's break this singleton approach. For doing that, I have created this class Singleton, same double check locking, and I have made this unit test to break the singleton pattern. Now the first way that I can break this is with reflection. Now how reflection works is, what we have done here is, in this line number 19 we are creating the instance of this class, which is very pretty straightforward. We are calling get instance method. For the second reference we will use reflection. So here we are doing singleton.get class get declared constructor. This gives the constructor of this class singleton, and we are doing here set accessible as true. That means even if we have declared the constructor as private, this line will override our access specifier and it will make it accessible to us. And here now we are able to create a new instance of singleton, instance 2. Now let's quickly run this. I'll put a debug point here and let's try to run this. Okay, let's see instance 1. We see 1729, instance 2 1730. Both the instances are different and this UT will fail. Let it go. And yes, so you see the error, assertion failed, expected and actual both are different because the hash code of both the instances are different. That means our singleton is not working properly. We are able to break this with the help of reflection. Now there is a second way to break it with the help of serialization. Now our singleton is implementing serializable interface. That means it can be serialized and deserialized. Now let's see what we are doing here is, first approach is pretty straightforward. We are creating a new instance of this class. Okay. For the second approach, we will be serializing this. We are creating a byte array and object output stream, and we are writing this object instance 1. We are serializing instance 1 that we received. Now again we will deserialize it. The same object we will deserialize it. We will again create a byte array. This time it will be input stream and it will be object input stream. We will pass this BIS and here we are deserializing it. Now the object that we will receive here in instance 2 is now a deserialized object. Now let's run this test again. Now you'll see that test has failed. Again, this is the serialization test and both the hash codes are different. That means we are able to break singleton. Now we'll see how to rectify this, how to make our singleton, double check locking singleton more robust, so that with these approaches we will not be able to break singleton pattern. Okay, so we saw that there are two approaches to break singleton, with reflection and with serialization. Now let's see how to make our class more robust. So with reflection we were able to call the constructor by invoking this set accessible as true. So I have made this new class and made some changes on top of it. It's called as singleton safeguarded. Okay, so here I have made this small change. If instance is not is equal to null, then I am throwing illegal state exception. So what this will do is, this If by any means a user or a class is able to access the constructor, it will first check whether if constructor is called and this particular object is not null, then throw this exception. That means rest of the code of the constructor will not get run, and this exception will be thrown, and the external class will not be able to create a new instance of this particular class. It will get an exception. So this is the first approach that we have done to safeguard this. Again, we'll run a test. This is the same test that we ran before. We are creating a constructor, we are invoking, we are setting the method as true, and we are creating a new instance, and we'll check whether both these are true or not. If both the instances have same, it will be true. But in this condition, when constructor would get invoked, it would throw an exception. So let's debug this code. Now we are running this test against Singleton safeguarded class, and we are trying to make a constructor. Okay, we have made this as true. This is also fine. But the moment we try to run this new instance method, we will get an exception. And so the moment we did this, we are getting an exception, and that was the whole point. User should not be able to create one more instance. So you see, now you will get this error, invocation target exception, and this through illegal state exception instance already present. So with this message, the external class would get to know that an instance is already present, and now they are not able to create one more object of this class. So one goal has been achieved. Now let's move on to the second goal. This is the same method. We are serializing and deserializing. Okay, now to safeguard from serialization and deserialization, what we have to do is we have to write a simple method, read resolve. In our Singleton class, we need to write read resolve method, and this read resolve method should return the same instance. That's it. This method would help us that during deserialization a new object would not get created. This read object would give the reference returned by this read resolve. Now let's see. Now let's debug this and let's check this. Okay, instance 2 assert same, instance 1, let's check 1792, instance 2, both are having the same reference. So this UT will, okay, now this UT is passing. That means both the instances are same. Let me make quickly one more change. Assert equals instance 1 comma instance 2. Let me quickly run this. And yes, both the UTs have now passed. So we have achieved, we have made this class Singleton safeguarded was made on top of the Singleton class. Two changes I did. One is inside the constructor I made this particular check, if instance is not null, throw the exception. And the other check was I added a new method, read resolve. What this method will do is it will return the same object. So during the UT, if you are trying to deserialize this particular class, you will get the same object always. So with these two ways, we have safeguarded our class. Now, This particular approach though is fine, but it has made our class more clumsy. We were trying to make a singleton, we were trying to protect it, but in doing so our code is quite large, right? And this is just the code which is required to save our singleton from breaking the pattern, to make it thread safe and all. But actual business logic will be done here during the constructor. Whether here we can make JDBC calls, JDBC connections, socket connections, or all sorts of calls which are resource intensive. So whatever code that you are saying, all this is just the piece of code which is required for singleton. Now, is there a better way to get this done with a lean piece of code where we don't have to make these kind of checks just to protect our class from being broken by some person who desperately wants to break our pattern? There is a way, and that way is much better. Let's discuss that. Okay, now we will see how to create a singleton with the best practices, the modern way to create a singleton, that is with using enums. Now, if you see this particular enum, this is one more way, or a modern way, or a much better way to create an object of a singleton class. So this is a singleton enum of, this is not a class, this is an enum. It has an object with this name, and this is the constructor of this. By default, the constructor of the enum is already private, and here we do not have to perform that check whether this particular instance is not null. Then we have to make a check that we were doing before, that throw this throw a runtime exception that this particular object is already present. We don't have to do that because enum will not provide the access to this particular method, this particular constructor. It will throw an error on runtime. It will throw an exception on runtime by default. So we do not have to write our own logic there. Plus, here you will not see that we have written read resolve method. Read resolve method is required for serialization and deserialization. This also is handled by default by enum. Enum during deserialization will always return this particular instance and not the new one. Also, in this code you will not see the double check locking. There is no synchronized block because enums are by default thread safe. They ensure us thread safety, and so there is no need to give synchronized block here, right? So our code becomes very lean. Just by calling this method, we will get the instance of this enum, and using this we can invoke any other method of this class to do the heavy lifting or to get the instance of this class. Okay, now let's see this in action. Now this is a singleton enum that we were just discussing. This is an enum, an instance object, constructor. Constructor is by default private of an enum, and get instance method. Now for this I have also written a test for this singleton enum test. Now this test is very straightforward and very similar to what we had done before. Here you will see that we have made a new instance of this class, enum, and we are invoking the constructor here, setting this as true, and now we are invoking constructor.new instance. Now let's see how this code would look. Let me run this. Let me put some debug points here. Okay, now we are here and it threw an exception. That means it is not allowing us to create a second object of the enum. That means it is still obeying the contract that we had set in the beginning, that this particular enum should only have a single object at all times. So with reflection we are not able to break this. Okay, now let's go below. This is okay. Now in this UT we are testing with serialization and deserialization. This is the first object, enum.instance, and using this we are serializing it here, and then we are deserializing it here. We are calling read object. Now this read object, if you remember, in our enum we are not having read resolve, but still this read object should give me the same instance. Let's run this test. Okay, now check I'll do a debug here. It is of type, the type is same 1751, and if you see this one also same, so this will pass the test. Okay, and equals also it will pass. So both the objects are same even though we are serializing and deserializing. That means with a very lean piece of code we are able to create an enum. We are able to create a singleton. No need to make an additional check in the constructor, no need to write the method read resolve, or there is no need to write the synchronize block. It's pretty simple, lean piece of code which works. So in your next job interview, if someone asks you that create a singleton, if you go with this approach, you will get some extra brownie points for it. Now this entire code can be found on the GitHub repository that is mentioned here. Also, I will mention the same repository into the description. Happy coding.